So our box finish printing, we've got our base here, nice and shiny silk silver on the inside. That slower speed really came through on that. I'm still kind of feeling out this Anycubic filament. I've got a few spots that I'm not thrilled with how it printed, but it's fast and it's good enough, so that's okay. Our face came out pretty good. I don't have a bright enough light to backlight it. I did have to give it a quick brush with the toothbrush after the black had finished on the first layer. Pulled a couple of little wisps out. I still need to figure out this Anycubic. If I was running the Polymaker, if I was running the eSun, I don't have those issues. The red and white printed beautifully, and those are my old eSun. The next stage in this is going to be putting the electronics in it, making that part work. And for lights, I found in my bin some 6000 Kelvin 5-volt cob LEDs. These are the ones I want to use. Anytime I make a box that has colors in the face, I want to use pure white light. I would rather use a 4000 Kelvin, a little bit warmer light, but I don't have any, so I'm using the 6000. It's just going to be a little bit cold for my taste, but it's still going to look really good coming through that light. In order to run that, in order to run all of this, I could just simply plug those in. Just give them power off of one of these little USB-C inserts, which is what I'm going to put in the box. That's what the hole in the side of it was. That'll just click right in, and it gives me the 5-volt power off a USB-C cable. I want to make this a little bit nicer than that. I want to be able to dim it. I want to be able to put it on schedules. I want to be able to control it remotely. And the easiest way for me to do that, the cheapest way for me to do that, is to use a D1 Mini and WLED. So these things are like $2 on AliExpress, at least. I don't know, $5 or something on Amazon. I just buy 20 at a time on Ali. Specifically, the Wemos D1 Mini version 3. These have these nice little screw holes in them that make them very easy to mount down. There are newer versions, like there's a V4, there's a Pro. Some do not have the mounting holes. You have to be careful if you want to run WLED, because WLED is not fully compatible with the S2 and S3 chips that you find on some of the Pros and other versions of these things. So very specifically, the D1 Mini V3. In order to drive the cob LEDs, which are non-IC, they are non-addressable LEDs, I need a driver for that. While the D1 Mini is capable of creating a PWM signal, it can't push the amperage or the the wattage. It can't power the LEDs. It just can't do it. So I'm going to take a data pin off of that and put that into this little guy, an AOD 4184. This is basically just a PWM generator that can handle the wattage I'm going to push through it. And what that looks like, if I switch over to this, forget that I have this this addressable strip in here. This was a different drawing, but it's perfect for this use. I'm going to take pin D1 off of my D1 Mini, run that over to the PWM signal side of my AOD, and from there I'm going to use just common 5-volt and common ground. So the 5-volt and ground from the D1 Mini will be the same wires that go up to that USB-C cable, and they'll be the same ones that connect down to the input side on my AOD. And then on the bottom of it, it doesn't say it in this picture, on the bottom of it, it says load, and that's going to be the negative pin up to my LED. What that'll give me the ability through my through the WLED interface, either programmed to have schedules and different scenes and whatnot, or just to pull it up on a phone or a web browser or whatever. I could go through and change its brightness, turn it on and off, whatever, you name it, for like $3 in parts, because the W1 is like the D1's like $2, the AOD's $1, it's like 94 cents. For like $3, I can make this a smart home connected lamp. Why would I not do that? And it's only a few solder points. So to get started on that, I need to take my D1, and I learned this lesson, embarrassingly enough, actually. No, come on. Sorry, cable's a little bit short. I learned this lesson unfortunately, on a chat with Polymaker. I was talking about LEDs, and I wanted to show off how this works, and I went to plug it in, and it lit up. I got the little flashy blue light, but then it didn't work. And I was kind of thrown. I was like, why is this not working? Don't plug these into USB hubs. They don't like USB hubs. Everything I'd done to that point, I have a cheap old laptop that I use, and I've been working from that, but since I was presenting like I'm doing here, I plugged it into my hub and it didn't work. Well, plugging it in directly to the computer is the way to go, so make sure you do that. Install WLED.me. It's what you need to go to. From there, I'm going to refresh it just to make sure it actually sees the serial port. Yay, it sees it. I know for mine it's COM5. It might be different for yours. There may be some drivers you have to install. Read their wiki. It walks you through that. Click the install button. Tell it install. I'm just going to run whatever the current beta is. I have no reason to run an older version. You can run older versions. I do like the stable branch 14 for a couple of things, trying to put user mods in and such. But version 15, usually whatever their current release is perfectly fine. We'll give this a second to install. Meanwhile, while that's running, let's see here. I should have buried. Here we go. So I've got another one here. Which one is this? Okay, so this is the Homeworld lamp that I have hanging on my wall. You can put in all these different preferences for how they run, what colors they run. You can go through and do all the configuration as far as what the segments look like. What I'm going to do on mine, on the one for this Helldivers, it's going to look a little bit different. Instead of telling it I have a WS281X, because I don't have addressable RGB strips, I'm going to tell it I just simply have a PWM white, because that's what I have. I'll put that on the appropriate GPIO pin, which if I go back and look at my picture, oh, that one doesn't have it. D1, I think, is GPIO, which one are you? D1 is GPIO 5, so I'll put it there. I have used 8, 7, and 6 on a lot of these with really good success. There are some like D3, don't put it here. If you connect something to this pin, it won't boot, and if you leave it connected long enough, it'll actually erase itself. So yeah, definitely read the tutorials from WLED. I'm going to start with D1. It's worked fine in the past. If that doesn't work well, I'll switch it over to D8. So, yay, installation complete. From here, you'll connect it to your Wi-Fi network and work from there. All right, so I've got WLED installed on that D1 Mini now. This is what the default configuration looks like. There's really nothing here. So first thing I'm going to do is come in and go to my LED preferences. I'm going to tell it that I have that PWM white. Is that the right one? Maybe that's not what I want to do. I think that's the one I want to do. Should be the one. Clock, normal, start, and GPIO. What was my GPIO? D1 is, go back to that other picture. D1 is GPIO 5. So let's pick GPIO 5. And that should be all I really need to do. There's other stuff that I will, of course, change in here, but that should be all I need just for the basics. And I'm setting this up because when I go over to my workbench, I'm going to mock this up with jumper wires first before I start soldering things, just to make sure it works. Never a good thing to solder it all together just to find out it doesn't work. So yeah, I'm going to go ahead and flip over to the workbench now. All right, welcome to the workbench. First thing I want to do is kind of mock this up to make sure it's going to work properly. And I need one more cable, I think. Hopefully I can mock this up properly.
Derp, derp. Derp, 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 derp. Derp, derp.
Okay, so that should work. When I turn this on, it shouldn't blow apart. Let's find out. Give it power. Now the default setting on this is not going to have the signal turn on, so I will do that real quick. And look at that. We've got light. I've just turned that up to like 50%, and we've got power. Let's see what happens if I turn it all the way. Well, at that point, we're exceeding, I don't know if you can see the display over here, we're exceeding 1.5 amps. That definitely works. I'm going to go ahead and turn that down. But yeah, my little mock-up definitely works. I've got 5 volt and ground connected to my D1 Mini. I've got the signal pin on D1 coming over to the PWM side of my AOD. I've got the blue pin is just connecting ground to ground. That's all that's doing. The green pin right here is connected to the ground of my LED. The red pin is the green pin connects to my ground. These two are just 5 volt out of my 5 volt source, and this is the positive off my 5 volt source. So cool. We know that it works. Awesome. Next stage from here, I'm going to break all this down and then put it back together actually soldered. Okay, to actually put this together, what should we do? Well, I'm going to start off by looking at my box and thinking about the distance on things. First of all, I need to put this guy in. And unfortunately, the way these things snap in, once they're in, you really can't do very much with them. You have to put them in order to work with them unless you're going to solder a connector on the end of them. Some of these come with connectors. They are, I think, pH 2.0s. You can get corresponding pH 2.0 females to plug them in, which do work fine. I'm just going to kind of push those pins in a little bit so that I can snap this in. I'm going to support the back of the print when I do that. Otherwise, you will pop your walls loose. Don't want to do that. That's in place now, and this is why I cut those walls down a little bit so that'll be nice and snug where it belongs without, coming loose or looking weird. So I've got that in. This is where my power is going to come from. I need to connect a few things up to it. The little standoffs that I had modeled in here are where these pins or where these devices screw in. So I can just take these, anchor them in place with 4 little screws. That's going to make my life a lot easier. Now that I can see where these need to be, I can start figuring out the spacing on them. I need to have a little wire coming from D1 over to PWM. So do I have any straps on hand that I want to use for that? I do not. Always grab more than you need. I'd rather cut a little bit off than have to go back and grab more. Need a little wire to connect those. I'm going to use white to connect to my LED strip. And if I start my LEDs up here, I don't even really need that to be very long. So grab a chunk of white as well. I'm going to need some red and black, which I have various bits of laying around. I'll use some of what I have left over. I'm going to need these on the D1 Mini to get bit power. I'm going to need some more black in order to connect the D1 or the AOD together. So we'll put some black out of here. Need a little bit that connects back to back on it, or I can just do it properly and actually group it all together. Need that. I'm going to need some red for my LED to connect it together. Red and black for those two, so I need 2 more red and black. That should be the wires that I need. We'll go from there. Okay, I'm going to use just the little guy for this. I'm not going to get the big one out. My little cheapie, it works. First things first, I need to connect the grounds together. I can do this a number of different ways. I'm just going to be lazy and pin these together. Let's go ahead and do that. Don't need a lot of exposed wire on this. A little bit is fine. Literally just the tiniest little amount. Solder contains lead. Lead is something you don't want to breathe. I built a little contraption here that will work as a solder extractor for me, a fume extractor. And we'll just go ahead and, come on. I'll set it up like that. That's probably fine. When you're soldering, one of the tricks that you want to follow, you want your soldering iron hot. You don't want it to be warm. You want it to be able to get heat into whatever you're soldering, into your wires, into your solder quickly so that it melts and bonds, but you don't want it to be so low that you have to sit there and hold it forever, because that'll damage your circuit boards, that'll melt back your insulation, it'll cause all sorts of problems. So I'm going to give this a couple seconds to heat up. I do suggest using a good, I like lead solder, sorry, I do, but make sure you get one that has a decent amount of flux in it. This is a 2% flux, and I love this solder. I've had others that have like 1% flux, and I've struggled with them. So a good fluxed solder, big help. Let's start with this. I'm actually going to flip this back over because I want this to be on the underside of it. And I'm just going to poke this through my ground holes. Use the little helping hands here to hold that wire in place. That way my hands can be free to actually use the soldering iron and the solder. Oh, come back here. Part of the trick on this, I should have a little bit more poking through, but I'm not that worried about it. Hold your soldering iron to the things you want to solder, let them get warm, give it about a second or two. Then add your solder, pull the solder away, give it another second or two, and you're done. That's all there is to it. See if that actually helped. I don't think that helped. Nope, that's on there pretty good. Now that it's actually in there, I'm going to reflow that. Just push up on my wire some. Get that wire to poke out a little bit. And probably put just a touch more solder on it, just to make sure. I wasn't perfectly comfortable with that. All right, that should be good. So this one I'm connecting ground to ground. Literally just going to wrap this over something. Here's a little hex key. Wrap that over. Down to here, it needs to be about that long. I'm going to cut off more than I need. I'm going to strip off more than I need. I can nip it off the other end when I'm done. Just a little bit taller than I want it to be, but that's okay. Let's strip just a tiny bit more off of that. All right, there we go. That's fine. This is just connecting ground to ground. Since this is all common 5-volt, common ground is fine. If I was doing this, this is actually pretty cool that I can feed it my ground and PWM on 5-volt on one side, and then I could put like 24-volt on this side if I wanted to. So it'll work with different types of LEDs, but since I'm just driving 5-volt, I'm just simply connecting them together here. So Hold it there for a second or two to heat everything up. Flow some solder into it. Give it another second or two. Pull away. Again, all there is to it. That's a good solid connection now. And I'll just take my snips, take off the extra, and we're good. We're fine. Cool. So that's the ground part connected. I'm going to need to connect. Next up is my yellow. This is going to be my signal line from the D1 Mini going into the PWM generator. So I want this to come in this side. Stick that back on there. Use the other part of the helping hands to keep tension on the wire. Grab the iron. Give it a second or two. Blow some solder into it. A second or two. Pull away. So that's a good solid connection there now. I need to connect my ground and my 5-volt to this, so we're going to grab 2 of those wires. The ground, I'm going to feed through this hole. Now, this wire is too big for this hole, but that's okay. We'll get it in there one way or the other. Clamp that down. Good old helping hands. Absolutely critical piece of equipment if you're going to be soldering. Give it a second or two to heat up. Throw some solder into it. I dallied on that one, but that's okay. Actually, leave that there because next I need to do the red wire. And I need to do the white wire too. Come on, there we go. That guy in there. I'm hoping the camera's catching this adequately. It's a funny angle for me to try and get this on camera and see it myself. Put some heat in it. Solder. Come on, there we go. And I need to do the white wire. That guy in there. Cheap little helping hands are falling apart. I got a much nicer set, but it's bigger and more obtuse. This little one does fine. Some heat on it. Flow some solder. Pull away. I was scrubbing the end off there, and that puts out a lot of smoke, so I was just bringing it to the filter. My extractor has a activated carbon filter at the top of it, so it's just safer that way. See where that's nice and neat? I'm just going to trim off the extra wire real quick. That's good enough. So this will end up being screwed down right here in our print. And I completely screwed up on that because that is in the way of my little arm. I meant to put this off to the side. I'll have to redo that. It probably doesn't matter. gives it character, because the screws are going to be what holds it down anyways. That's fine. I could have done that over the top. It's fine. Whatever. All right, next we need the D1. Where's the D1? It's right there. On this guy, I need to give it power, and I need to connect D1. So we'll get to the 5-volt side of things first. Same procedure as before. I'm going to take 2 of my wires. These are going to go in the top, so I'm going to flip this over. Fortunately, these things are labeled on both sides. Got my 5-volt and my ground, so we'll start with 5-volt. Feed that through. Go ahead and solder him in. We'll grab the ground wire. That in place. The gauge of wire you use for the D1 really doesn't matter. You can use thin stuff, thick stuff, whatever. When you start working with your LEDs, for the load-bearing wires, make sure you're using an adequate thickness, a high or a low enough gauge of wire. You don't want to try and push, like a 50-watt LED across a 28 gauge wire or something like that. You want to make sure the wires are thick enough to carry the power you're going to push through them. The next step is going to be putting these two together. And that's where trim those down. Don't have to trim them down, I just like to do it. I think it looks neater that way. We're going to go to D1. So if this goes in here, I need about, wrap that over my finger, not my finger, let's use something smaller. Just kind of fold it over. This is a stiff solid core wire. It's not stranded, so it bends and holds its shape really well. I need you to go from here to there. So about that much. Not even that much. Hold it down there. That gives me a little bit of extra to work with when I screw it up. So I'll take that off right here. Save that for later. And I'm going to strip off a whole bunch of this. I'm going to strip off like that much. Down. That'll work. That'll be just fine. Now, how am I going to clamp this together? Let's see here. I'm going to put you there. I'm just going to let you hang loose. That'll work. Kind of position my wires to where good enough. Stay there. Going to keep. Nope. Hold still. There. That'll hold it in place. Going to heat it up. Put some solder. Give it a second. And part of this, I'm going to reflow it just to make sure it got down in that socket. In that little through hole. Nip off the end. Throw it in the dumpster. And with that, I could screw these down. they're ready to go. So let's move this out of the way. All this out of the way. Before I screw this down, I'm going to go ahead and put the LEDs in here. And what I recommend when you're installing your LEDs, just like you keep your bed clean so your print sticks, you want to keep your print clean so that your lights stick. I do that with an alcohol prep pad. Anyone who has to take an injection for medication knows exactly what these are for. Get them at first aid, whatever. I get tons and tons of them through the pharmacy as a part of some medication that I have to take. So I'm just going to wipe this thing down. Just so, when I've been sitting here touching it and playing with it and whatnot, those finger oils are taken out of there. That doesn't really break the finger oils down, but it does help. Now, for the LED. I'm going to start by, first of all, trimming back some of this extra. That's a lot. And get this down to something I can use. I'm going to peel back, and I don't even know what brand this is. I have no idea. It's just whatever was on sale on Amazon that day. I'll try and put this at an angle you can see it. I'm going to peel back a little bit of this. And I'm going to line it up with the bottom of my translucent strip. Now, usually the lower you go, the better, but these have a very high angle that they shine at, so it's fine at here. If I was working with SMD LEDs, the ones that have little chips in them, I would want to put those down lower so that they have more of a chance to broadcast that light out. One of the things I love about cob LEDs is I go around squishing this down. Cob LEDs are very flexible. The actual LEDs themselves are very, very small, so you don't have to contend with the fragile nature like you do with SMD LEDs, where they can snap off and break. In fact, I can really cram this into that corner and then peel back the backing and really fit it in there. You can't do that with an SMD LED. If you have a resistor in there, if you have the actual SMD itself, it probably wouldn't like that. I'm just going to keep running this around, touching it down as I go. This is part of where rounding those corners off back in Fusion helps out. Not immensely. I mean, we didn't put huge radii to them, but having not so sharp corners makes this adhere a little bit better. It'll stick better over time. Plus, it's just easier to get on there. So, pulled that a little bit too far. Jam this down into that corner. Keep going. I'm just kind of pushing it into the print as I go. I'm trying to stay, oh, I went a little bit high there. Need to roll that back a little. Try not to do that, because every time you pull it loose, it's a little bit less that it's going to stick. Don't want to cover up any of that transparent part. It's kind of my guideline as to getting this on here. And trying to keep your spool lined up with how you're feeding it in will help you keep it aligned. And keep going and going and going. Yep, just hit the camera with my forehead. Sorry about that. One of the cool things with non-IC LEDs like these cobs, you can add and draw power anywhere along the sequence. I can literally use these contacts right here if I wanted to add LEDs elsewhere. Just solder them right in and you're fine. Can't do that with the IC LEDs, with the addressable LEDs. You can do that with the power, but you can't do that with the data line. They are sequential and they have a direction. They have a, forwards and backwards. Okay, how much do I need in here? So I'm going to cut this off. I'm going to slice this off right about here. This is a little bit more than I need, but I'm fine having a little bit of waste. It's going to make it easier for me to maneuver. Go ahead and stuff this into here. Since the crown is kind of a feature of this, I want to try and get as much of this in here as I can. What's kind of nice, these crown pieces are actually going to act a bit as a retainer. As the strip tries to unfold itself, it'll just push harder into the wall and hopefully stay in place a little bit better. You can add like hot glue to these, you can add super glue to these, whatever you want to do. I've never had to, even with these cheap LEDs that who knows what they are, they say 3M adhesive in the listing, and this is absolutely not 3M adhesive. Okay, so while that wasn't a lie, I did decide to use my little 3D doodle pin to reinforce these just for a warm, fuzzy feeling. But even with the cheapies, they'll stay in place just fine. Let's push this one back in. You can cheat and use tools if you need something to help push into a fine area. Now, what's cool on these, for the end of it here, you can cut this off wherever you want. If you cut it off at the solder point, you can add more to it, but you can cut it off anywhere and make that the end of the strip. So for this one, get that out of the way. I'm just going to knock it off right about there. Maybe a little bit more off of that. Right there. And that's it. We've got our lights in. If I still had all the wiring mocked up, I would be able to turn that on and it would work. To just very quick simulate the lighting before I plug all the other stuff in. Get my probes back out. And just throw it on at full power. Make sure I don't short out. That would be annoying to cook it after it's done. If I get that power, we've got lights. Put my faceplate on it, we've got a clean light. So I'm happy with this. If I was just making a basic light with no special controls or anything, all I'd have to do is solder those 4 wires together and call it a day. I'm done. If you want to do it that way, you can use like a Wago strip or whatever. That's perfectly fine. You can get external dimmers, like an actual dimmer that plugs into the USB port. You don't have to use a USB port. You can use a 5.5 by 2.1 DC jack. I think I actually have one of those like floating around here somewhere. I don't know. Lots of different ways you can do them. I just like using USB-C because it's fairly universal. Like, who doesn't have extra phone chargers laying around? All right, so we're good there. I need to get my screws. I'm going to need my shrink wrap, so I'll leave that out. All right, screws. I love this little kit. So I've got some M2.3s here. think that's what the WeMost needs. I always forget if it's the 2.3 or the 2.6. 2.3. Go ahead and screw that in. Sorry for the cut. One of my kids had a bad dream. Anyways, where was I? Need to put the AOD in now. So I need 2 smaller screws for that. I think those are the 1.7s. 1.7 by 5. One thing I learned with these tiny little screws, do not over torque them. They will snap off. Okay, so our components are now in. These out of the way. Next step is just to solder a few things together. Got so much length on here. Honestly, I probably could have just dumped these right in there. I might actually do that. Wait, no, because this one goes to my white. I could just take the white one out. Put this one in there. Yeah, the white one's unnecessary. Oh well, I'll keep it together. I'm going to cut everything to roughly the same length, so I have less to bundle up and put away. Yeah, about there. Get rid of those scraps. Strip these down. Get a decent amount on these. And end up twisting them together. I might wire wrap these two. It's unnecessary, but it does make it cleaner. And when I'm doing this, I'm being very careful to only pull against the wire. I'm not pulling off of where I have these soldered down. Okay, so I need these guys to go together. I need you in the mix as well. Put those and this one about there. Come on. There we go. These four, the 5-volt positive, all need to go together. Go ahead and do that. Again, I know my hands are getting in the way. I'm trying not to do that, which is making this a little bit more difficult. Let's get them all twisted together like that. course, my soldering iron went to sleep while I was in the other room. I need this one to join the party here, so we'll get him trimmed down while the soldering iron warms up. And you two are going together. Move that out of the way. I've got my ground for here, and ground itself. Just kind of twist those together real good. And this is so much extra. But using a little bit of extra makes it easier to move everything around. Okay, so just like in our mock-up, I've got all of my 5-volt positives together. I've got my input ground, the ground to the D1 and the ground to the AOD together, and then I have the ground for my LED connected to the load of the AOD itself. Time to touch up some solder. So I'm here to start putting some heat in the wires. Plenty of solder. Some heat in my wires. Lots of solder. Got enough hanging on the soldering iron, this will probably be fine, but that should be it for the soldering. In fact, at this point, I think I can even test it. So to do that, I'm going to grab my USB-C cable, and we'll give it power. Look at that. Works great. So, just a little bit of housekeeping. I need to get my shrink wrap, knock a little bit off the ends of these. They're just a little bit long, anywhere that it's not twisted together. For the shrink wrap, I'm going to go with second size up to make sure it fits over everything. Yep. And take off more than I actually need. I'm going to use like a finger's width on these. And I can actually go probably down to my smallest one. This guy. Nope, okay. Okay, whatever. Just use more of this. Put this away. For heat shrink, I'm going to get this down here nice and good, cover everything up. Make sure that I'm a ways down on my sheathing for these wires. I'm intentionally leaving a lot at the top. I'm pinching it to make sure I've left that extra up there. One of the things I love about my soldering station is I have this rework tool that's just a very focused hot air gun. Where my soldering iron was set to 375 degrees Celsius, I have this set to 275. And it will shrink the heat shrink without getting all sorts of nasty garbage on my soldering iron, and without having to use a lighter or whatever that puts all sorts of soot everywhere. What I'm going to do is get these good and hot. In fact, I get them from the different sides. I'm going to get this one nice and hot. I'm just going to bear the pain and pinch it. And that hurt a little bit, but while it's hot and soft, I can seal up the ends of it. So that's it, it's done. From here, it's just a matter of housekeeping on the cables. And I'm going to grab some wire harness tape. Same stuff I use to line my cardboard spools. Tie all this together. And since I have some of that solid core wire in here, push it down and it'll stay in place. So with that, hey, you're supposed to be off. It's cooling down. I'm sorry if that's loud. So when we printed this, or when we designed it and then when we printed it, we put these little notches in here, these little rounded off components that have mated receivers in the base. I'm just going to click those in. And with that, we have not only the friction fit of the print, but we also have, that ain't coming off. That's on there good. Turn the fan off, get that out of the way. And grab that USB-C cable again. It's all tangled up. Plug it in, turn it on. And there's our light. That's it. From here, it's just a matter of any kind of customization you want to do in WLED. Of course, you'll need to set this up so that the recipient can connect it to their Wi-Fi at home. What it'll do is it'll go into a kind of a rescue mode and allow you to connect directly to it, and then you can bond it to your home network. So yeah, just that one tiny little point right there that I'm not happy with. But other than that, that's a nice clean box. We've got the bias lighting coming through pretty nicely. So that'll light up the wall around it as well as the print itself. And yeah, that's it. I don't know if it's had enough time, but maybe we'll get a little bit of that glow-in-the-dark charge. So given a little bit longer, that'll take. I'm happy with that. And let's see what our power draw is. If I crank that up to its absolute brightest, full power, I'm pulling about 1.15 amps, just short of, call it 5.6 watts, 5.7 watts. That probably looks horrible on the camera. Let me see if I can adjust that. I bet you I can adjust this on the camera settings so it actually shows up correctly. We'll try it. These things always look horrible to cameras. I think if I drop down my exposure, I don't think I can go any lower. It's kind of what it looks like. It's a little bit, it's like in between those two. You know, the red is much more even to the eye. Can I turn off? Nope. They're hard to photograph, but it works. It looks good to the eye. I'm happy with this. Maybe I'll turn the gain down. Hey, look at that. There we go. That's about what it looks like to the eye. Good clean lines, nice and sharp. I'm happy with this one. I think it's going to make a great birthday present. So, thank you for watching.